Welcome back to the classroom, everyone. I'm Aaron Olsen. Before we get into today's lesson, please make sure to smash that like button, subscribe to the channel, and follow the account so you never miss an update on our A+ masterclass. Today, we are mastering network troubleshooting with a visual diagnostic framework for CompTIA A+ Core 1 Objective 5.5. Let's dive in. As always, we start with the CompTIA troubleshooting mindset. You must follow this 6-step process. Step 1, identify the problem by gathering info, duplicating the issue, and questioning users. Step 2, establish a theory, question the obvious, and research. Step 3, test the theory to confirm the cause or establish a new one. Step 4, formulate a plan of action and implement it safely. Step 5, verify full functionality and implement preventative measures. Finally, Step 6, document your findings, lessons learned, and outcomes for the next technician. Moving into Section 1, we tackle physical and environmental failures. This is what happens when the physical path of your data is broken, degraded, or blocked by the real world. Let's look at port flapping. A common support ticket here is a wired connection dropping and reconnecting every few seconds, causing the network icon to flash. By definition, this means the network interface card, or NEC, or the switch interface is continually transitioning between up and down states. Run through your diagnostic flow. First, check cables and replace any damaged patch cords or verify structured cabling termination. Second, check hardware by swapping the host to a known good switch port. If it still flaps, the host NIC is faulty. Finally, check the switch config using its management interface to review up state durations and error rates. What if the network fails every time the warehouse machinery turns on? The root cause is electromagnetic interference, or EMI, or crosstalk corrupting the physical data frames. Check sources like nearby power lines, transformers, heavy motors, generators, HVAC units, or fluorescent lighting ballasts. For troubleshooting actions, inspect cable terminations for excessive untwisting, which causes crosstalk. Reroute cabling away from heavy machinery, or upgrade to shielded twisted pair, or STP, cabling in high EMI environments. Wireless signals have their own physical blockers. If a user loses Wi-Fi when entering the break room or using the microwave, radio frequency signals are being blocked by dense materials or overwritten by overlapping frequencies. Concrete, wire mesh, foil-backed plasterboard, and mirrors absorb or reflect signals. Microwaves, cordless phones, and Bluetooth devices cause frequency interference on the 2.4 GHz band. Here's an exam tip. 5 GHz has faster speeds and less interference, but 2.4 GHz has better physical penetration through walls and a longer range. To fix this, move devices closer or reposition antennas to bypass blockers. Section 2 brings us to logical connectivity and access blocking. This is what happens when the cable is securely plugged in, but the network still says no. If a user reports a yellow triangle on their network icon and can't reach the local server, they have limited connectivity. The host establishes a physical link, but fails to receive an IP configuration from a DHCP server. Your primary exam tip here is APIPA, or Automatic Private IP Addressing. If you see an IP address starting with 169.254, the device is using APIPA and can only communicate with other APIPA devices on the same local segment. To resolve those DHCP failures, look at the scope of the problem. If it's a single user, suspect a bad switch port or incorrect VLAN. Verify the wall port connects to the correct switch port and VLAN ID. If multiple users are affected, the DHCP server might be offline. Leases take hours to expire, so this symptom rolls out slowly across an office. Another cause for multiple users is DHCP exhaustion, where the server ran out of available IP leases. Check the DHCP scope and either expand the pool or reduce lease times. Authentication failures often pop up when an older laptop won't connect to a new corporate Wi-Fi network. Root cause 1 is simple user error. They entered the wrong network password or passphrase. Verify those credentials. Root cause 2 is a standard mismatch. The access point might be using a security standard like WPA3 that the older client adapter does not support. Fix this by updating client drivers or configuring the AP to use a legacy compatibility mode. However, warning, enabling legacy modes like 802.111b slows down the entire wireless network for everyone. What about intermittent internet connectivity? The user can print to a local network printer but can't load any websites. Windows reports no internet access because the adapter has a valid IP but cannot reach external sites. Follow this diagnostic flow. Step 1, ping the default gateway or local router. If yes, the local LAN is fine. Step 2, ping an external IP like 8.8.8.8. If no, check the router's WAN link status or contact the ISP. Step 3, if you can ping external IPs but websites won't load, verify DNS resolution using the NS lookup command. Now we enter section 3, performance, speed, and quality. This is when the network technically works, but the user experience is terrible and slow. If file transfers to a shared drive are crawling, check 3 main things. First, configuration, check for duplex mismatches. A gigabit adapter connected to a switch port must be set to auto-negotiate, as forced mismatch settings throttle speed. Second, drivers. An outdated NIC driver can severely impact throughput, so check the vendor site for updates. Third, capacity. Isolate the scope. If the whole network is slow, look for network congestion, like a user transferring massive amounts of data, which overloads the switch or router. If Wi-Fi drops completely in the far corner of an office, you have intermittent wireless connectivity. For distance and walls, remember the RF signal weakens with distance, so move devices closer to the AP or deploy an extended service set. For channel overlap, if multiple APs broadcast on overlapping frequencies, very common in 2.4 GHz, packets collide and connections drop. The fix is to survey the area and manually configure APs to use non-overlapping channels, like 1, 6, and 11 on the 2.4 GHz band. To properly survey the area, use a Wi-Fi analyzer to measure the received signal strength indicator, or RSSI, in decibel milliwatts, or dBm. Exam tip: dBm is expressed as a negative number, so values closer to 0 represent a stronger signal. Negative 65 dBm is a good, reliable signal. Negative 80 dBm is too weak. Packets will drop and the adapter will disconnect. If RSSI is too low, the adapter slows down the connection, like dropping from 144 megabits per second to 11 megabits per second. You need to try and maintain stability. If a user says their Zoom calls sound like a robot and audio keeps dropping, you have poor VoIP quality caused by network congestion. You need to know the difference between latency and jitter. Latency is the total time it takes for a signal to reach the recipient, measured in milliseconds. It is a steady delay. Jitter, however, is the amount of variation in delay over time. Packets arrive at erratic intervals, breaking real-time audio buffering. The fix for VoIP issues is implementing quality of service, or QoS, or bandwidth control on your router or switch. QoS recognizes real-time protocols like VoIP and video and puts them in the fast lane, prioritizing their packets over standard data, like web browsing during times of congestion. Keep these VoIP threshold exam tips in mind. The maximum tolerable one-way latency is 150 milliseconds, and the maximum tolerable jitter is 30 milliseconds. As we wrap up, here is the Objective 5.5 Quick Reference Matrix. Review these primary causes and checks for everything from port flapping to poor VoIP. If you have limited connectivity, look for that APIPA address. If you have intermittent wireless, check your RSSI and channel overlap. Finally, never forget the golden rule of diagnostics. Whenever a stable network suddenly experiences limited connectivity, authentication failures, or slow speeds, always ask the user and yourself, what has changed? Isolate the variable, and you isolate the fault. To make sure you're ready for exam day, finish your study session by getting some hands-on practice with PBQ-like questions at XP Boost. The link is in the YouTube video description. Thanks for watching, and I'll see you in the next one.